All right, and welcome back. Still on this flight, really long flight. So good thing is nobody else is on this plane with me, so I get the whole plane to myself. Pretty cool. Anyways, hopefully you're able to watch the last video on the introduction to our cross sections and our volume, and hopefully you enjoyed watching those different graphics. I think it definitely helps to see those and just get a different perspective on things. Okay, so in this video, I'm going to show you a couple examples of calculating the volumes of some of our specific shapes, in particular of prisms and pyramids. Okay, so if you're ready to go, let's go ahead. I'm going to pull up those notes and we will get going here. Okay, so again, in the last video, the beginning part, we identified the shapes of cross sections formed by cuts to a solid. Right, so if I were to cut off a piece, what two-dimensional shape am I looking at? Right, in this video, we're looking at determining the volume of prisms and volume of pyramids. Okay, so quick recap. What is volume? Volume is the measure amount of space that the solid encloses. So how much space is inside that object? Okay, as you recall from his video, we measure that in cubic units. Okay, so if I have a 1 by 1 by 1 cube here, right, let's say there's centimeters, I would have centimeters cubed, or inches cubed, or yards cubed. All right, now, when I'm looking at a different shape that's not a cube, I'm essentially saying how many of those cubes can I fit within that sphere? Okay. Now, as he mentioned, the smaller you make those cubes, the closer you are, the more accurate you are to that volume. Now, we're not just going to approximate it with cubes. Okay? People have done that, and they have done the calculations, and they have come up with formulas that essentially say if I squish these cubes down, okay, and I make it into this sphere, what is the exact volume? So that's what we're going to be looking at. Okay. So first of all, volume of prisms. So the volume formula is the area of the base times the height. Okay. Now you will see this written as volume is big B times H. Now remember, big B is just the area of the base. Okay. We had that in our surface area video, so don't get that confused. Big B, area of the base times the height. Now, if you recall, in his video, he talked about the vocabulary, right? The terminology. It's all, depending on who you talk to, it's all different. Okay? So the height, we'll take a look here in this case. Right? What is that dimension? Well, if I look at this triangular prism, okay, remember, area of the base. Well, I want to know what is the base of this prism. Okay, so if you were to ask somebody, what is the base of this triangular prism? They would probably say, well, it's sitting on this rectangle, so that's obviously the base. I'm going to say, no, that is not the base. Okay, the base of a triangular prism is the triangle. Okay, because we've talked about a prism, it has two bases and they're identical. Okay, so I'm always going to look at, if you want to think, the base is always the non-rectangular piece. Okay, so in this case, the triangle. We could have a hexagonal prism. It's the hexagon. Okay, they're always going to be the sides that don't touch each other. They're parallel to each other. Okay, so if I want to find the area of that base, remember it's 1/2 base times height. So in this case, I'm going to have 1/2 times my base of the triangle, 6, times the height, which is 5. So that's my big B. Now, this height, so this is where the terminology gets a little tricky. If you were to ask somebody, what is the height of this prism? They would probably say 5. I would say no. Okay, because when we're talking the height of the prism, we are talking how much distance is in between the two bases. So if you were to stand this prism up on the base, how tall would it be? Okay, so we're looking at this 11 here. That is our height. Now, in his video, and I didn't show you this part, but he talks about the length extended. Because if you remember, a prism's created by, if I take this base and I extend it into the page to the other base, how far is that? So his formula is actually area of the base times length extended. Okay, so I'm going to show you both. I'm telling you both, but I will just tell you it's the distance between the two bases. So in this case, 11. Okay, so if I were to calculate this, 1/2 times 6 is 3, 3 times 5 is 15, 15 times 11 is 165, and we are in centimeters, and since we're talking volume, we are cubed. Okay, so just keep that in mind. Again, I think the hardest part about the volume calculations is the terminology. So let's take a look at another example. And volume of this triangular prism. So remember, area of the base times the height. So if I look at this guy, I first have to think about what part is the base. Well, it's the non-rectangular piece. So I look at this triangle. So that's my base. And again, you look at, I have to have two bases that are parallel to each other. They're not going to touch. So those are my bases. Okay. So if I want the, again, that's a triangle. So our volume here is 1/2 the base of that triangle, which I'll call 8, times the height of that triangle, which is 5. Okay. And then I want to multiply that by the height. In this case, is actually the height because it's standing on its base. Okay, so I would multiply that by 3. Okay, so then 1/2 times 8 is 4, 4 times 5 is 20, 20 times 3 is 60. We're still in centimeters and we are cubed. Good, good, good. Okay. So now, why did I start with a triangular prism? Okay. Why not start with a rectangular prism? Well, in this case, remember I said the base is non-rectangular, right? Well, in a rectangular prism, all of the sides are rectangles. So in this case, it doesn't matter which side you consider your base. I can consider the front my base, right? Or I can consider the top my base, or the bottom, or the side. It doesn't matter. In this case, I'm going to go ahead and consider the front. Okay, so my volume is going to be 8 times 60, because that's the area of a rectangle. And then I'm going to multiply it by the length extended. Okay, that's times 120. Well, think about what we just did, right? In his video, we talked about terminology, but essentially we took length times width times height. Right? So that's the reason why I started with triangles, because when typically when we ask somebody, how do you calculate volume, or what is volume? Students normally respond length times width times height. Well, that's not always the case. That's only the case if we have a rectangular prism. Okay, so I don't want you to fall into that trap. This is only for rectangular prisms. Okay. Now, if it is a rectangular prism, obviously here it's fairly easy to calculate. So I have a pretty big number here, 57600, so 57,600. We are in feet and we are cubed. Okay, so that is how much water is in this. In this case, we're looking at an aquarium. Okay, very large. All right, so that's a triangular prism, that's a rectangular prism. Really, that formula is true for any prism. Okay? We are just dealing with triangular and rectangular prisms, but I could have a trapezoidal prism, right? The base is a trapezoid. We could talk about a cylinder, which we'll actually do next week, but they're all the same. I just take the area of that base, the non-rectangular face, times that length extended. Okay? I could even apply that to these guys, because if you notice, these are all prisms. The front of the shape is the same as the back, right? They're parallel to each other. So those are prisms. So to find the volume here, I would just find the volume or the area of this front piece, and then I would multiply by that guy. Or I could find the area here, right? This has a hole taken out of it, right? It's hollow in the middle. So I would just take the area of this triangle minus that rectangle and then multiply it by this 14. Or in this case, I could take the area of this triangle plus the area of this triangle plus the area of this rectangle, add those up, and multiply that total by that 6. Okay, so that's how I could go and find the volume of these composites. Okay, I could even have these irregular shapes. This isn't technically a prism, okay, but it has the same base on top as on bottom. So if I wanted to technically find the volume here, I would just take the area of whatever shape this is, times whatever that height is. Okay, so again, essentially, it's the same equation for all of these. So just wanted to point that out too. Okay, now the prisms that we have been dealing with are all what we call right prisms. Okay, right prisms because they stand straight up and down, they create right angles. Well, what happens if I slant this? Okay, so I take the top, I slant it, so now it's a slanted prism. It's what we call an oblique prism. Okay, so I still have top and bottom bases that are exactly the same. So how would I calculate that volume? Well, to answer that question, let's first answer this. Okay, the toughest question of the year. Which of these triangles has a greater area, A or B? I'll give you a couple seconds. Think about it. So what did you say? Triangle A or triangle B? Hopefully, you saw that, hey, they actually have the same area. Because if you think about the area formula for a triangle, area is 1/2 base times height. Well, they have the same base down here, and then they have the same height. So we're essentially plugging in the same numbers, so the areas are equal. So they have equal area. Well, one's slanted, one's standing straight up. So how is that possible? Well, I'm not changing the height, I'm not changing the base. So I'm not changing anything. If you think about the cross sections here, right? I take that cross section at the same height, I take that cross section, it's the same thing. Okay? So I'm taking those two pieces. Well, let's apply that to a three-dimensional object, right? I take a stack of coins. Let's say these are quarters, let's say I have 20 of them. Well, if I slant it or I push the middle over, have I changed the amount of money? Obviously, I haven't taken anything away, right? So if you think about they're stacked up, well, that height is going to be exactly the same. I'm not changing the height of each of these coins, these quarters, so that has to be the same. The base is 1/4, so I'm not changing that. So if we're talking how much money, well, it's the same money, so the volumes have to be equal. Okay, so really those calculations would be exactly the same. What we're talking about here is what we call people pronounce this differently, Cavaliere's or Cavaliere's principle. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. Okay, so essentially what that's saying, all of these have the same height h. They all have the same base. And if I were to take out a cross section here or here or here, those would all be equal. Okay, which we know in a prism, all of those cross sections are the same as the base. Okay, so what that tells us is these volumes are all equal. So I calculated it the same exact way. Volume of an oblique prism, it's the same equation. Area of the base times the height. Now remember, that is a perpendicular height. Okay, so let's just see how I apply that here. I have this triangular prism, I've now slanted it. So if I want to find the volume, okay, I take the area of the base, so that's 1/2 times 10 times 4 times the height of this prism. Now when you calculate this, I have two numbers. I have this 12, this 14. This 14 is going along this slant. So remember, that's the slant height. I do not want that. I want the perpendicular height. This is the perpendicular height. That's what I need to plug in. Sometimes you're given it, most of the times you're given it in our problems. Sometimes you might have to calculate. Okay, but that's what I want to plug in. Okay. So then I take 1/2 of 10, which is 5, 5 times 4, which is 20, 20 times 12, which gives us 240. We are in inches and we are cubed. Okay. All right, so that's essentially what we're looking at there for our prisms. Doesn't matter if they're right or oblique, you calculate the same way. Okay. Now, where we're going to jump to next is volumes of pyramids. Now, here's your equation. Okay, volume of a pyramid is 1/3 area of your base, so big B, times the height. Okay. Now remember, again, perpendicular height. So why is that 1/3 here? Well, here's a little visual. So if you have this rectangular prism here, right, you could actually split this into three pyramids. Three pyramids that actually have the same volume. Okay. So that volume of this pyramid is 1/3 of that rectangular prism. So remember, area of the base times the height is the prism. So I'm taking 1/3 of that. So there's just a little visual to maybe curb your curiosity of why is that 1/3 there. Okay, but you just got to know that equation: 1/3 area of the base times the height. Okay, so if I'm looking here, I have a hexagonal pyramid. Okay, now I want 1/3 area of the base. Well, luckily in this case, we don't have to calculate that. They already give it to us. Remember, that's the big B. So in this case, I'm taking volume is area of the base, 22, times the height, which in this case is 5. Now, sometimes they might give you that slant height. Okay? Remember, that's not what we want. Okay? You always want the perpendicular height. So I'm using this 5. Okay? Sometimes they might not give that to you, so you have to calculate. Luckily, they do here. So all I do is 22 times 5 is 110, and we are in centimeters cubed. Okay? Hopefully you're seeing, well, this is centimeters squared. So there's 2 centimeters there, and then centimeters there. So there's 3 centimeter units. Okay, so that's where the cube comes from. Okay. All right. So now, if I want the volumes of this is a composite shape, remember, but really the only new thing here is I have this pyramid. Okay, so I want to first look at, well, how do I calculate the volume of that pyramid? Okay, because in the bottom, really, if I look at the bottom, it's just a rectangular prism. So the volume of the prism, okay, that would be our area of the base, 3 times 6 times 6, right? Times your length extended. So 3 times 3, or 6 times 6 is 108. Oh, sorry. So just keep that in mind. So I just add that to the area of the pyramid. So let's find the area of the pyramid. Okay, so volume of the pyramid, remember that's 1/3. Area of the base, well, the area of the base is just a 6 by 6 square. Okay, it's a square pyramid. Now I need times the height. Well, again, here, as I mentioned, we have this 5, but that's the slant height. I don't want to use that, right? I need to find, well, what would this height be if I drop this straight down to the middle there? Okay, so I have to do a little calculation. Well, luckily, since that's a regular pyramid, I know that's 3 because it's half of this guy. Okay, so now I can do some calculations here. I know 5, I know 3. Well, remember, 3, 4, 5. You can use Pythagorean theorem, but I know right off the bat that's going to be 4 inches tall. Okay, if you need to know where that comes from, let me know. Again, we can go through that calculation, but I know that's 4, so now I can just multiply all these out, and I end up with 72 inches cubed. So now I just got to add those together. I take 72 plus 108, and I end up with 180 inches cubed, or cubic inches. So that's how you would find the volume of your composite shapes. All right, so to sum this up, okay, we've got the volume of our prisms. Volume is area of the base times the height. Now, again, keep in mind that base is not always the bottom or the top. It could be the side. Okay? So find that non-rectangular base and then multiply by the length extended. Okay? So the length between your two bases. Okay. Volume of your pyramids is 1/3 of that. So 1/3 area of the base times the height. Okay. Remember, that's always your perpendicular height. So just keep those in mind. Again, that's the trickiest part here. Okay. But if that makes sense to you, I think you're good to go for this week. We'll take a look at the other shapes next week. So ended up here in, if you know where this is in Oregon. This is Trillium Lake. This is Mount Hood. I'm going to go and climb that mountain. So while you move on to your quick checks and your assessments and your practices, hopefully I'll be up here. Okay? If you have any questions, hopefully I can still get online. I will be. I'm kidding. Anyways, again, jump online with us. Last 2 weeks, we want to see your faces. We wanted to say hi to you before summer. So get on to our Google Meets, 9:30 to 10:30 with Mr. Sutherland, 1:30 to 2:30 with me. Again, we'd love to see you. So jump on. Let's have a conversation. If you need help with math, we'll help you with math as well. Cool? If anything, hopefully you're healthy. Hopefully you're staying safe. Hopefully, again, as this weather, it's a beautiful day today. So get outside, have some fun, run around. Anyways, okay. Hope to see you soon. If not, have a great week. And then we will catch you when we do. Awesome.